Okay, guys. So, hi, welcome back. I hope you enjoyed your yellow day yesterday. So I just wanted to clarify some of the vocabulary terms for all of you. So, I went ahead and I made some drawings, and then I used some images off of Google. So, just please be kind. I'm not an artist, all right? So, looking here, we have a Bohr model of an atom. Okay, so we have our nucleus in the center, and then we have our rings or our orbits around them, and they're assigned quantum numbers 1 through 7. Okay, so quantum number is literally just a number assigned to each orbit of an electron. That's it. Okay, so we just need to remember that each black ring here represents an orbital. In an orbital, as we know it, basic, plain simple, it's just a space where you're likely to find an electron. That's what an orbital is. Okay? So Bohr's model says, or it states, that when n equals 1, you can have a maximum of 2 electrons. When it's 2, you can have a maximum of 8. 3, 18. 4, 32. Okay? So Bohr's model is not the current model that we use for our atom because it doesn't work. All right, so this light blue down here at the bottom where it says, using mathematics, scientists determined that each orbital can only have a maximum of 2 electrons. All right, so 18 and 32 electrons is not possible when we get past hydrogen. Hydrogen has 1 electron. That's why Bohr's model works perfectly for hydrogen. But if we're looking at tungsten, not going to work. Okay? So, what we use today for the model of our atom is what we call the quantum mechanical model. Okay? So, I know there's a lot of different definitions out there, but it's just the modern description of the atom. It treats electrons like waves, and basically it's based on math. Okay, so we use various equations and we came up with atomic orbitals that our electrons could be in. All right, so plain and simple. Here in front of us, I have a 1s orbital, a 2s orbital, and then a 2p orbital. Okay, so principal quantum numbers, n. See this 1, 2, 2? That is our quantum number, but our principal quantum number is 1, 2, 2. Okay, so quantum numbers and principal quantum numbers are basically the same thing. Quantum number, Bohr, principal quantum number, our current quantum mechanical model. Okay? The lowest energy level is 1. So if we're in our lowest energy level, we're going to have a principal quantum number of 1, and that's going to be our ground state. Okay? So looking here, this red is our atomic orbital. That's the space where we could find an electron. Notice, as we go from our 1s to our 2s, the red space gets larger, okay? So as you increase your principal quantum number, you're increasing the size of your orbital, and your electron is going to spend more time away from the nucleus, that black dot in the center, and your atom's energy is going to increase, okay? I know this is a lot. I know this is confusing. It's okay. So, moving on, our atomic orbitals. Okay? We have different energy levels, right? So, going back here, we know that n can be 1 through 7. So, we have 7 different energy levels, all right? I explore the first 3. Okay? So, if our energy level is 1, that means we have a 1s sub level. Now, remember, going back to our vocabulary, we have S, P, D, and F sub levels. So we have 4 sub levels. okay? And those are represented by our SPDF, all right? So if we have an S, looking at 1, if we have a 1s orbital, it's going to be a tiny sphere, and you can have 2 electrons possible, right? So each orbital, each shape can only have 2 electrons. If we go to our second energy level, we're going to have a 2s possible and a 2p possible. So notice here we have our 2s sphere, which is bigger than the 1s, and we have the 2p figure eights, if you will. All right, people refer to them as dumbbells. I don't know why. That's just what my college professors did. They kind of look like dumbbells, I guess, to some people. I prefer to call them figure eights. Okay, so our circle, our sphere, can have 2 electrons. So our 2s can have 2. How many figure eights do we have? We have 3. One of them can have 2 electrons. So if we have 3, that means 3 orbitals times 2 electrons each gets us 6 possible electrons. Okay? Moving on to our third energy level, 3s, 3p, and 3d. Our 3s orbital is larger than both the 2s and 1s orbitals, and that can still have 2 electrons. Okay? Our 3p orbital, again, 2 electrons total for each different shape, and notice they are bigger than the 2p. Okay? And then your 3d, I cannot draw these. These are hard, all right? The 2p, the p orbitals is where I stop. So on the next slide, I have our 3d orbitals. Don't panic. I know it looks crazy, okay? So there are 5 possible orbitals in our d sublevel, okay? So each one of these green shapes can hold 2 electrons, okay? There are 5 of them, so that means we have a possibility, or we have 10 electrons possible, okay? I know. This is our F orbital, okay? So I know I don't talk about this yet. I haven't mentioned it yet, but we have F orbitals, okay? So we have 7 orbitals. Each purple figure can hold 2 electrons. So 7 orbitals times 2 electrons each gives you a total of 14 electrons. Okay? Here's a table that breaks it down. All right, I don't know where to put myself. I'll hold myself here. So again, we have our energy levels 1 through 4, our different sublevels, and they've aligned it nicely in a nice row so you can see the number of orbitals per sublevel, and then how many electrons we could possibly have. Okay? I know it's a lot, but this is just to clarify some of our vocabulary.